see. I mean, really, I think from startup, go ahead, just go through the tutorial on the platform, on the actual POC platform itself, and we'll have some questions about history and whatnot after the fact. Sounds good.
Yeah, no problem.
Alex.
No, yeah. I definitely that. Robbie gave me a little bit of an update today. It's always I never know everybody's experience level in the world of rod pumping and rod pumping optimization. So I'll just kind of start from the ground and work my way up. But try not to get too into the weeds on stuff I'm pretty sure you guys are probably quite familiar with. I guess the first thing I'll bring up. So I'm just looking. I'm going to bring up our hardware real quick. I think it's a good start, but yeah. So, anyways, so my name is Dallas Barrett. I'm actually from Canada. I still live here. I have my whole life, but I feel like I'm half Albertan and half Texan. I've pretty much spent half of my life in bouncing around the likes of Texas and well, pretty much anywhere there's oil. Um, uh, and so a lot of people ask me, why don't you live down here? Well, last week I was in Midland. The week before that, I was in North Dakota. There's a good chance I could be in Oklahoma this week, if not next. So I don't think it would really matter where I lived. It would be an airplane in the duffel bag either way. And so, but anyways, I'm quite familiar with Texas, and I love it down there. And that's why I want to go come golfing with Robbie. I know he's very good at booking tee times and stuff, and hopefully you guys have been able to leverage that a little bit.
The best in the business.
So I guess they call me the general manager of automation. As you guys probably know, Wellworks was acquired by Liberty Lift on May 6th of 2024. I'm one of the original Wellworks members. I've been in this industry for about 23 years, 8 years at Lufkin, 8 years at Champion X, and 8 years at Liberty Lift now, I guess. So I've been around and I really enjoy this kind of stuff and this is my favorite part. I love doing presentations and not doing inventory counts and profit and loss reports. So I appreciate you guys giving me an opportunity to get out of all that other not very fun stuff. But anyway, so the first thing I'm going to start on is just the hardware. I'll spend less than a minute and a half on this, but I think it is important as it is, a key differentiator in this industry. And so we partnered with Red Lion and for our hardware. So this is the brain of our controller. It's the Red Lion DA70N Flex Edge controller. And what's unique about this is Red Lion is upwards of 1 million RTUs a year in sales, and their familiarity within the automation world is quite extensive. I wouldn't say it's anything like an Allen Bradley or anything like that, but if you guys have automation guys on the call or on your team, I'm going to say that there's a really good chance they're quite familiar with some of the operating software or configuration software that Red Lion has to offer. And so, for a lot of companies such as like Continental, they have some pretty heavy hitters. In the Red Lion world, it's made it very easy for them for configuring communication networking stuff, static routes, this kind of thing. And but I think most importantly, what it's done is it's really, given us what I would say is probably one of the most stable pump off controller platforms, because we're not circuit board builder guys, and we're not building a circuit board that has one purpose in life. So because this thing is put into so many different environments, the research and development that was put into it was, much more than, my life at my previous two companies. And I think that has, that has folded into a reliability improvement, maybe times two, right from the very start. And so, for example, the very first Ken Well Manager that was installed in the world is installed about an hour from my house. It's been through 4 winters now. It's still the original, what Red Lion would call the demo hardware, and it's still going strong. So I think it's a decision that our customers will really learn to appreciate as well. the other piece that's unique to this platform is what it comes integrated with, and the way you can, we call it kind of a future-proof platform. So, for example, it comes with a 4G LTE cellular sled built into it, so you don't have to make an investment on communication infrastructure, right? Well, there's a 5G cellular sled that's going to be available right away. If we feel the need to upgrade to it, it's a very inexpensive way to just upgrade to 5G, should you ever need to. So this is the cellular sled here, this portion of it. This is a dual Ethernet port sled, and this is just a USB sled. So the configurability out in the field to fit the need out there is pretty flexible. And even to now, if I roll over to what's beside it, I have a sync. This is our synchronous module. This is a I/O module, and then you can have as many as 10 of these modules added onto this. And there's many different offerings that are coming down the pipe from Redline. One of those being like a backup battery sled or module that I could slide on there. So we continue to work with Redline in that department, but right out of the box, this comes with, essentially any communication equipment you'd ever need to add to a pump off controller, and hopefully saves you the cost or the requirement to do so. This is a cloud-based device. I don't like to say the word cloud dependent, because I think that's the wrong way to look at it. We're pushing this technology forward as fast as we possibly can. And you need this sort of platform enable, to give us that ability to do so. So we have over-the-air firmware updates. I can update the firmware in the display, the firmware on the Redline, the firmware for the Ken Well Manager application. Okay, and with that comes, technical support. I know for a fact that we've saved our customers a lot of money on service calls that we would have sent somebody to location, but it was something we were able to fix remotely. And so, with some other products, you can't. XBOC is quite limited in that it's a Modbus communication platform, and we're much beyond that. So there's a lot of things we can do remotely that you would normally have to go to site to do. And I will say this: please stop me and pause me if there's any questions in regards. That's the hardware. So this is the main portal that you sign in through. When you get your well set up, you'll get an email notification. You'll set up your username and access, like many other products you guys are familiar with. This portal will continue to grow. For example, we have a rod design software, a cloud-based rod design software called DesignWorks that will be available very soon. We're testing it on just a laptop version right now. There's a lot of reasons why we're having that product built as well. That'll be something that pops up into this portal. You can see this thing called the GreenShot. It's a fully automated fluid level machine that uses the well zone produced natural gas to shoot a fluid level. So that I'm hoping that we can have available maybe as early as the second quarter of next year. And in order to add that product to your Ken Well Manager, you just simply add one of those modules I just showed you to your existing platform, and you have the capability to shoot fluid levels and read your dynos, and then use the combination of those inputs to calculate things such as pump intake pressure, for example, which is very complicated and difficult to calculate from just a downhill cart alone. Casing fluid gradient, it's something that I think is often overlooked in this industry, but it's something that's very critical to the optimization of a rod pumped well. If I can tell you that you have a very, very low casing fluid gradient, there's some things that we can make some better decisions on from an optimization standpoint. So keep that in mind. So I'll just go ahead. I'm just going to click on the Ken Well Manager. I don't know if for those of you who have maybe been around the industry for a while or not, Dr. Sam Gibbs and Ken Nolan are the pioneers of Dynagraph cards and the Dynagraph card industry. Dr. Sam Gibbs came up with the wave equation to give us the downhole card from surface load and position measurements in 1967. And so they are the pioneers of it. For those of you that are familiar with the Lufkin SAM controller, that controller was named after Dr. Sam Gibbs. And so being that Ken is so near and dear to our heart and to this industry, we felt it was only essential that Ken had a controller also named after him. And that's where the name Ken Well Manager comes from, is Ken Nolan. Still doing really well. His 90th birthday is actually in 2 days, and I took him out for lunch in Midland last week. When I drove up to his place, he was driving his lawn tractor, jumped off his lawn tractor, and sped walk over to me to shake my hand. So I feel like he might outlive me. But so I'm going to go ahead. You can see you can search the well tree for well names. There's a map view as well. And there's group status view, which, for those of you who previous Xbox users or current Xbox users, you can use your group status for different pieces of information. If you guys do have a third-party SCADA system that you do like to share some data with, that's no problem. We can in fact, we can use our cell modem in some cases to communicate to your SCADA system if you wanted to do that. If not, we can just tie a radio to an Ethernet port and produce that data. But I'm just going to go ahead and click here and take you to the I guess the first and most probably commonly used page is the well status page. We don't have a card up yet because it'll have to complete a stroke while we're here. But so here I'm just into this well. If I look here, I have a blue box on the top left, and my well state is running. Control mode is village. Handoff auto is an auto. Elapsed time 7 days, blah, 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 blah. There's no remaining downtime because we're in VFD speed control. But this blue box here, if there was a violation, the blue box would turn orange. If there's a malfunction, the blue box would turn red. And so there's stages of that. So it's very, very obvious when you log in here. If there's a problem, you're going to know about it immediately. Something else that's good is if you connect external devices to our I/O, such as a vibration switch or a leak pot or a permissive from a facility, you can apply text to each of these shutdowns. So it'll tell you exactly what that shutdown is. Resistor bank overheat, a Robbie, a Robbie fault. And there's probably a few of those around. We let Robbie wire this thing, or George, But yeah. So anyway, so it would tell you that in this right here where it says no malfunction, it would spell that out. Here we have the equipment loading data. We are not yet bringing gearbox torque calculations into the equation. It's a very complicated thing to do accurately when you include things such as what does Ken always call it? It's basically like a momentum thing. So we can calculate gearbox torque at one point, one moment in time, but we can't compensate for this I can't think of the word. It doesn't matter. But what we are going to do is we're going to go ahead, and in this case, I believe we should be reading the motor torque from the VFD here, and we're going to apply a gearbox, a gear ratio to this, and then we can come up with an accurate-ish gearbox torque. And again, I warn you that any gearbox torque I think you've seen from anywhere, they're not going to be nearly as accurate as what some might think. And so there's also a lot of data that's required to collect for accurate gearbox torque in different manners. What type of is a double ORO way to, where's the position of it? Do you have one on both sides, so on and so forth? So I think the path of using the electric motor torque and torque curve to then calculate gearbox torque, although not perfect, it'll get us as close as we can. But I just wanted to point that out. That's something that we get a lot of questions on, and certainly something that we do have in our roadmap coming quickly. The next thing is just polish rod horsepower. And then our highest loaded rod taper is 98%. If you go ahead and click this, it'll tell you the rod loading of each of your tapers. Now, one thing to pay attention to there, if it's a high strength rod and it's entered as a standard steel rod, we're going to calculate, potentially a little higher loading than what it might actually be. So you want to make sure that we have the correct data or as correct data as we can entered in. Operational status, again, pretty straightforward today and yesterday. 100% runtime here on this guy. Obviously, when we see 7 days, you can see our minimum loads and our peak loads are not changing a whole lot. So we're, this is probably a well that we could maybe go ahead and speed up, but this isn't my well, so I won't do that. But it doesn't seem like we're changing a whole lot of things. Maybe this thing is totally optimized. I mean, here we go. It's going to start pumping off as I say this. So this could be an extremely optimized well, and that's why we see such consistency from day to day. Pumping unit average speed looks to be very similar fluid load currently. Last stroke min and peak load. And in our very next firmware, what you will see right here is our tubing and casing pressure. If you tie in some analog tubing and casing transducers, we'll be displaying that here. Any questions this far? Okay, I'm going to keep going. Robbie, you can still hear me, right?
Yes, sir.
Okay. Production status. So we have oil, gas, and water. Those. That's a simple. It's separated. Go ahead. Go ahead. Sorry.
Hey, real quick.
Yeah.
Bad area. I'm not breaking up here. So this is your cloud-based platform, right? For the
Correct. Yeah.
Okay. So, I mean, this is something that we all wouldn't use right now. I mean, it might be something we add down the road, possibly. I don't know. I mean, it's kind of slim. Do you have some type of tutorial that actually shows us, if you can connect, or, if you have something more on a URL, you can kind of GUI into one of these POCs, direct IP? Do you have something like that you can show us? Because that's how we're going to test it right now.
So I'm not sure if I totally understand the question. So there is a local display that is the exact same user interface as this. Okay. The Kenwell Manager can't survive without this. So whether you use it or not, it's there. Does that make sense?
Yeah.
Yeah.
Okay. Yeah. Okay. That makes sense.
Yeah. And so it's the exact same user interface locally and remotely. And I mean, I can give you a million bullet points as to why we're going this direction. I've heard it a million times. Hey, we don't need that. And the very next day, these guys are just absolutely, in love with it, right? And so when you think about, let me give you some examples. Okay, so I'm going to show you something that we've patented called plunger velocity. And plunger velocity has brought a whole new thing into the world of optimization, maybe almost similar to the downhole card importance, okay? Well, this just showed up on January 8th, 2024, without any of our customers even lifting a finger, right? So there's features such as that require this cloud infrastructure, okay? And our controller is different. So if you look at like a typical SCADA system and a device out in the field, the SCADA is the master and the device out in the field is the slave. So nothing happens without that master requesting something. If it doesn't request it, you're never going to know about it. It doesn't matter. And so we've flipped that script, okay? The controller in our system is the master and the cloud is the slave, right? So why is this important? Well, I'll tell you what, if you go get a lightning strike on any of the competitors' controllers, the data in that controller is gone forever for life. You can't, it's gone. There's nothing, even though Xbox might collect some data or Signet or Foresight, they don't collect all the data. Modbus is very limited, right? We can go drop a Red Lion back in and in a matter of 20 minutes, all the data that was ever there is replenished and you're just back up and running rod string data, so on and so forth. So that's one piece of it. The over-the-air updates, things like deviated wave equation. Okay, this is something we're testing right now, and we hope to have out by Christmas. Minute by minute data. That's in our very next firmware release. So the connectivity to push this technology forward and the rod pumping industry itself forward, this is really just a necessity. And so we have a lot of customers that use third-party systems and so on and so forth. But I mean, by all means, once you get familiar with it, I think you'll find it very, very useful, and you'll probably use it a lot more than what you thought you might. And so let me go ahead. Let me just jump ahead a little bit and show you like the plunger velocity, for example. And so here, in this case, we're plotting, the plunger velocity through the pump barrel, right? No other controller on the planet does this. You can't get this data from XBlock. You can't get it from Foresight. We've patented all and everything to do with plunger velocity because we believe so heavily in this as an important piece to allow us to make better decisions. So every controller on the planet makes a speed up or slow down decision based on pump village, okay? Well, how many wells out there are we slowing down because we have a low pump village, right? Maybe 60% pump village, but we have a 7,000 foot fluid level, right? How do I know? How can I pump confidently through that situation where I have a fluid level up the yin yang and I'm going ahead and I'm going to go ahead and slow my well down? It doesn't make sense. We're leaving a lot of production on the table. And you can have the best gas separator in the world. That doesn't mean that you're going to separate all the gas downhole. So now I have plunger velocity. And I can show you a million examples of where, because I have plunger velocity, I can go ahead and make the decision to speed up or stay the same speed in a condition where I have a pump village of about 60%, for example, right? Where every other controller and every other thing on the planet is going to tell you to slow down. This isn't, as Matt would say, Robbie, this isn't your grandpa's water flood. The onslaught of horizontal multi-stage frac, or just multi-stage frac in general, has completely changed the dynamics of rod pumping and all forms of artificial lift, for that matter. But the algorithms haven't caught up to this, right? So we're using vertical wave equations, and we're using pump village to control these wells that have high fluid levels. And so that's what we're here for. We didn't come here to build another pump off controller. We've done that before, and we didn't even want to do it. But the problem is, and the fact of the matter is that this technology just wasn't being pushed forward to the best ability of the customers, or the best use of what's required to maximize production, minimize costs for our end users, for our producers. And so if you look at this plot, for example, when I have a full card, I don't know how familiar you guys are with plunger velocity plots. The only other way to get it that I've ever seen is like an Ecometer dyno, which is obviously a short-term thing. But in this case, here's my zero line, okay? So this is 0 feet per second through the pump barrel. My maximum velocity in this case is about I'm about, say, 4 feet per second, okay? And you can see it waver throughout. These are just your general harmonics that you see in the surface card. That's replicated in the downhole pump velocity to a certain degree, obviously with less magnitude. And you can see at the end of each stroke, we get to 0. And then we go ahead and, you typically in the middle of stroke, you go back to your maximum velocity. And so I think you get the idea, but yeah, there's things that I think this cloud connection is a real treat, and it gives us this ability to continue to optimize our wells and learn from our wells as quick as possible. I think Robbie could probably speak to this too. We try to roll out firmware about every 12 weeks. A lot of that is requests from our customers, right? So I like this here, I'd like that there. For example, the tubing and casing pressures displayed on the well status page. Well, that came from a customer, so I think you'll really learn to love the system and the program. There's other reasons too, okay? So as much as people think Modbus can give you live signals. It can't. I mean, it's a very slow way to. It's a very slow protocol. It's very limited in what it can send and receive. And the way that we transfer data, which is a secure WebSocket, is as much as 50 to 100 times faster. Now I know we're not frac companies; we don't necessarily need that speed, but there's a lot of pluses to this. So, like I'm showing you live load and position data. I can use this to troubleshoot, load cells or position devices here. I don't know if this guy. I can look at my VFD speed live with my position and load data. Let me grab you a different well and show you some other things that this is really handy for. So I'm just going to go to one of these guys here. So if any analog signal that you add, so for example, is my pump connected? Is my well heading off? Is my well flowing? Okay. Well, this is a really good way to tell. I live in this page a lot actually. So I'm going to look at just position and tubing pressure. This is, I mean, I can tell you right now, the pump is connected on this guy, and it's really good to learn, you can see in this case, there's about a 7 or 8 PSI difference between, downstroke pressure and upstroke pressure. Well, there's a lot of things we can do with that data outside of that. If this was a well that started to head off, we could likely identify it by knowing the pattern of this thing. So this is just some examples. Again, one thing I'll point out, this is a Ken Well Manager call, so there's just tabs across the top of this, right? And so don't be scared to bounce around in here. There's nothing that can make you blow the system up. A lot of that deep stuff that could potentially, cause harm or do miscalculations, so on and so forth, is really in the background and not accessible from this side of it. If not that we want to hide stuff from our producers or our customers, but there's a lot of things that I can't even make sense of. I mean, how many the friction coefficients, and how many times do I want to run the wave equation every stroke? There's a lot of things we just don't need to see, and it makes the display or the user interface way too busy. So we just try and give what's important to everybody on this front end. Is there any other questions there? I was going to go through the control setup real quick around the VFD. Robbie, are you guys, is Trinity looking to have a variable speed package?
Yes, sir, they are.
Okay. Well, and again, slow me down if there's any other questions. I hope I answered that question. I'm just going to go ahead and minus this so it's a little bigger. So I'm just going to, so here.
Yeah, I think you're good on your end, Alice. I mean, it's the biggest thing is with, what I'm, treading lightly on is basically our cyber, if we're going to intertwine any type of communications back to like a cloud-based system with all our communications, I mean, that's a red flag for us. We'd have to have that approved through them, and whatever, hey, if y'all are having y'all's own base communications to be able to communicate back to cloud, to this cloud, interface, I think, I want to make sure that
good question.
I'm on the same page here.
Right. Let me answer. Yeah. Okay. I see where you're coming from. Let me answer that a little better. Okay. So there's a number of different layers to that. This is your data. You own it. Okay. We don't change nothing, so on and so forth. Only you have access to this data along with our support team. Okay. And then, but secondly, on that piece from a security standpoint, we have these conversations every day. I'm an electrician by trade, and I'll tell you, I've learned more about cyber security than I've ever cared to in my life. Okay, and it's because of this system. And so we're actually chasing what's called a SOC 2 compliance, which is the same level of cybersecurity standards that your banking system in the United States is held to. Okay, all of our communications are in a private network. Everything is, so we talk secure WebSocket, so on and so forth. So I guess what I'm really saying is we can answer any of those questions, obviously on this call, but any of those concerns or any of that thing, I'm confident we can make your IT or any of your team feel comfortable with this technology. We have a million different ways to go about it. You can actually supply your own SIM card for this cell modem, for example, and just allow outbound traffic to our cloud. Do you know what I mean? So some of the IT departments and stuff in these companies are more comfortable having being in their network and pushing it to us, for example. So we have a lot of different flavors. All 32 flavors of Baskin Robbins, as Matt would say, to appeal to the. I'll tell you what. Let me say it like this: we have to sell this to more IT departments than we do to production engineers. So we're pretty. The production engineers are the easy ones nowadays. So we're pretty geared up in that department, and I think can satisfy almost anybody. Okay, so let me go through this. So again, we keep the status values coming through. Here we have 4 different control modes available: pump intake pressure, timer on, off, and host. I'll just go through fillage because 99.9% of all users use that. In this case, our pump fillage is set for 80%. We're calculating 100%. And let me just scroll down here. So in this case, we're not in SPM, but you can swap it as you see right here. You can go from Hertz to SPM. It just takes a simple calibration. But in this case, my target fillage is 80%. The fastest that I can run is 70 Hertz, and the slowest that I can run is 30 Hertz. Okay. So now if I make a decision to speed up, I'm going to speed up by 1 Hertz. If I make a decision to slow down, I'm going to slow down by 2. And if you look at the deadband and deadband plus or minus, what this deadband strokes mean is, am I going to make a decision whether to slow down, speed up, or stay the same speed? I'm going to make that decision every stroke right now because my deadband strokes is 1. If I wanted to make that decision every 2 strokes, I just go ahead and change my deadband strokes to 2. So I make that decision every second stroke, and so on and so forth. I think the limit is probably 5 or 10, something like that. If you get beyond that, you probably want to start considering constant speed or something like that. But keep in mind, in rod pumping, we are stopping at the top and bottom of every stroke. So the last thing as a well optimist that I'm scared of is making speed changes too often, because it really is not hurting the system whatsoever when you consider the fact we're going to 0 at the top and 0 at the bottom. But let me explain that. So the deadband percentage then puts a little window, if you can imagine, around the 80% fillage. So let's just say that my pump fillage is 82%. My decision for that stroke is going to be to stay the same speed that I was the last stroke, because I'm plus or minus 3% of the 80. And so it just gives you that sort of helps give you a little bit of a softening, and that you're not, necessarily changing strokes changing speed, every stroke, for no gain. Whether or not it hurts the system is not necessarily always the way to look at it, but am I gaining anything by this decision? If not, let's try and not make those decisions as often. Now there's something else here we have called secondary fillage. So in this case, they have this disabled. But I would say, Robbie, you probably know this better than I do, but probably 60-70% of our customers with the variable speed control systems use secondary fillage. And what that is you set this typically 10, 20, 30% below your target fillage. And what it does is it prevents you from, for example, if in this case right now with secondary fillage disabled, I could sit and run at 30% Hertz, or 30 Hertz, at 10% fillage all day, every day. There's nothing to stop me from running in that scenario. So if I enabled secondary fillage and I put it at 50%, for example, if it got below 50% for oops, in this case, they have it for 3 strokes allowed. So if I had three strokes below 50%, I'm going to go ahead and stop the unit for 10 minutes and then fire back up and go through that whole scenario again. So I'm kind of a fan of secondary fillage. I believe most wells today are still, in that part of their life cycle where, they are carrying some fluid levels, albeit, maybe a gassy, a low gradient fluid level. But I think that it's a good thing to have. So let me just go here. So let me talk. Yeah. So okay. So that's that. In this case, constant speed 60 hertz is not being used. If I put it in host mode, then it would go ahead and it would flip to 60 hertz. When do I use that? Well, typically, sorry, just give me one sec. I might use that if I have an end device problem. Can you guys hear me? I just had to swap AirPods here, so.
Yeah, we can hear you, Dallas.
Okay, perfect. Okay. If I had a load problem or a inclinometer problem, I might want to go ahead. I might be inclined to go ahead and kick it into constant speed. Or, maybe I just did a hot oil or a chemical treat or something like that. I don't want it changing speeds. I want it to get after it. Those are some different scenarios that I've, witnessed our customers using constant speed for. Not something that's usually used a whole lot, but certainly another tool in the toolbox. Maybe it's a brand new startup. You just want to get after it at a certain speed and see how the well reacts. That's how that works. The beauty is you can still shut down on peak load. You can still shut down on min load, malfunction set point. So it just basically ignores pump fillage decisions is a good way to look at it. Something else we have is zone control. So in this case, we're not using it. But there's 4 different zones. In the very next firmware, there's actually 12 different zones. So you can pick the position at which you would want to make the speed change throughout the entire stroke. This is more commonly used with like a Liberty Lift XL unit, the 366-inch stroke lengths or the 416. We'll use zone control to soften the cornering just due to the nature of linear lift in itself. Again, we'll use plunger velocity to help us set those speed changes a lot of times. And then there's other guys that swear that if they have a fast up or slow down, they get a little better gas separation. In fact, I believe there's been some papers presented on that. So that can be applied on a conventional unit or any kind of rod lift with a VFD. So just something else to look at. I don't want to change anything. Malfunction setup. Okay, so here I got 27,000 pounds. I can violate this for 1.1 second. Okay, that might sound like not a very long time, but trust me, a half a second is really too much. You can miss. If you violate it for 0.3 seconds at 27,500 pounds, now you're back below 27,000. You're not going to shut off. And again, it doesn't sound like a lot of time, but when we got playing with this, we had our default set at, I don't know, I think it might have been 0.7 or something, and it was just too high. There was instances where we were missing things we should have been shut down on. So we actually changed the default to 0.1 or 0.3, but I'm seeing 0.1 almost everywhere I look. So I think it's 0.1 is what they changed the default to. Also, I think we're the only ones that do it by time versus stroke. So you don't have to complete the stroke before the fault. Minimum load works the same way. And that would incur the violation that would turn that blue box orange. But also, once that's completed, it's going to shut down for 5 minutes, and it'll be allowed to repeat that as many as 3 times, and then it'll stay down indefinitely until there's some pumper, or, there's some somebody has to come have a look at it. Malfunction set point, for those of you who aren't familiar, that's this little green dot here. The way that works is if we start our upstroke and we have trash in our pump or, something wrong with our pump, and we cross underneath this green dot, we're going to go ahead and shut down instantaneously. And there's many scenarios where your minimum load or your maximum load won't catch certain things going on. So the malfunction set point is really there to catch those scenarios. We do have a customer that probably needs to have some chemical warfare on their side, but for whatever reason, they just tend to live off this malfunction set point and just reset the well whenever they get this violation. I think there's some other things they could do, but it's working well for them. They went through many rod strings before this. I don't know what kind of trash. If it's, I think it's some iron sulfides and stuff they're fighting, but it's working well for them. They're happy with it. Something else I'll point out too on these violations or malfunctions is we can email or text you on any of these faults. So if there's something in particular that you'd like to be notified on or all, just let us know and we can also have that set up. Low fluid load. In this case, it's 3 strokes before it shuts down. And it's allowed to violate or to restart 3 times after a fluid load violation. So again, each to their own, depending on the well. You can tailor these faults to that. Position fault. We use an inclinometer for position. So we have a position fault here. In the event that you broke your belts, the unit wouldn't sit there and just continue to run the electric motor. A 4th shutdown switch. I don't know what, that's what they named it. So that's what it is. If that turns to a 0 or a closed, it can violate it for 0 seconds and there's 0 retries. Same with leak detection and Presco. VFD fault and vibration switch. So they're allowing the VFD fault to happen for 1 second, but there's no retries. So none of these, they must consider them all quite critical. Any questions on the malfunctions piece?
No, sir.
Okay. Man, you guys are easy. This either that or I'm not doing very good, Robbie, but it seems like we might have a little bit of an experienced crowd here. I'm going to go through the history here real quick. As I said, the very next firmware, the 3 big things that we're bringing to the table, one of them is every minute data. The other one is, I call it high resolution data. The other one is compatibility with the HoloFX kit, or at least the first phase of it. And I can't remember what the third one is, but there's 3 big items that are coming down the pipe for that next release. Robbie, you might remember what it is. But I'm excited for the minute by minute data. I think that'll help us optimize some of these wells. What we do in the meantime is we save 1 card every hour on the hour, and then any event card. So you can just go in here and click. When you come here by default, it'll select all the malfunctions and violations, but you can just go ahead and you can click those off if you'd like. And I like to sort of scour through my hourly cards. When you're specific to some optimization opportunities, or why when I sped this well up, did I lose production? You can go ahead and go through this. In fact, I just had one case where I believe, which isn't always the case, but the well started flowing, and for whatever reason, when we were running faster, we would lose overall production, not only inferred production, but they confirmed it with the measured production. So we, obviously went ahead and kept that well down below 5 strokes a minute and kept the production as high as we could. But we could sift through these hourly cards to see, to confirm some of our thinking.
Hey, Dallas, real quick.
Yeah, go ahead.
What's your limitation on your card history?
It's unlimited,
Unlimited.
And so I hate to say that because I know there has to be limitations on everything, But I think in the world of this, card data is such a small, it's so small in the world of data that we're in today that, we save every card that's ever been saved for an eternity thus far. Not to say that we might cap that sometime at maybe 3 years or 5 years, something like that, but at this point, essentially, it's limitless.
10-4. Thank you.
You betcha. We have over, I believe we're just about to probably 5 or 6 million cards now in our card library, in the historical data piece. So, and it hasn't been, it's been a non-issue altogether. Yeah, so let me go back through history here a little bit. So there is the production and operation history. So you have, runtime, minimum load, peak load, all this kind of data. And it's just like, booking your hotel room, just hit apply, get your dates, hit apply. And again, this is where you're going to see some super high resolution data come out in the very next firmware resolution. A lot of our customers initially, when we started selling the Kenwell managers, were very dependent upon these third-party SCADA systems, and so they were building their own historical data. So it wasn't a huge rush for us to get that in here. Although we have saved every stroke of data since day one, we just didn't have it displayable. So now we have customers that live entirely within this system for the rod pump wells and not anywhere else. So we've had a lot of requests for some, I guess you could call it SCADA type improvements on the user interface piece, with minute by minute data being one of them. You can also save this, print it, however, and something else too, I'll just say, same with the cards. If you see this little save button, if you hit save, that card is now saved in history. And if you go to the card library, it'll be under the reference card. So this will be the card I just saved right now. And then I'm going to go over to configuration. So we try and put everything you need to program the Kenwell manager in one spot. And so start at the top, work your way down, or you can just click all. I have a lot of customers that actually use that instead. But yeah, so the well settings, when do I want the production time to stop and start? So if you're monitoring or measuring production, on these wells on a 24-hour basis, and you want to synchronize the Kenwell manager inferred production data with your production measuring equipment, you can just go ahead and set this time to whatever time those are gauging off or starting to record, so you can match true 24-hour data periods. Surface equipment, pretty straightforward. Stroke length, stuffing box friction, unit structure rating. This is one spot where, for the most part, people use the default values. But certainly some of this can have an effect on things such as inferred production, especially if you get changing like formation volume factor and what have you. So the more accurate information you can enter here, the more accurate information is auto calculated here. But again, not a lot of customers touch this. However, we do have a lot of customers that are living off of the inferred production calculation. And the minute we're 20% out of their measuring equipment, we usually get a phone call. So it might be, sometimes auto calculate may not be the best way to do it. Rod string info. So we only have 4 different types of rod strings right now. We don't have the manufacturer, all these kinds of things. When we plug DesignWorks into the system, it comes with the entire rod database that we've built. So I believe it'll cover 90 to 95% of anything our customers use. As far as manufacturers, also we'll have the option to, if you guided or not guided, co-rod will be something else that comes as well. So all these kinds of things. Tubing, This is really just to calculate tubing movement. If we do see it, the tubing is anchored, it's anchored at this depth. And then last but not least, the bottom hole assembly. So, how deep are we? What's the true vertical depth? What's our plunger diameter? What's the plunger clearance? And what's the plunger length? And so all of these would be taken into consideration when we are inferring calculation off of our downhole cards. And that's kind of, that's the first glimpse up to there. The IO page is not something necessarily a lot of our guys touch. I like to sort of take them through it just to show them the functionality. But you can see here we have our analog inputs. Everything's broke out almost by the way that those modules or those, the IO modules are set. But, so in this case, you can see your live tubing and casing pressure, just like you can on the signals page, full line pressure. We can see load and position, so on and so forth. But here's something I like to sort of show you guys. So I double click on DIO5, I can name it what I want. So I just click custom, name it leak detection. And then if I want to have a malfunction of it, I can just go malfunction, false open, 0 retries allowed, so on and so forth. So any digital you have, you can go ahead and connect to that. And same here, if you have a tubing pressure that you'd like to shut down on, you can go ahead and enable this malfunction and say, if my tubing pressure gets to 300 PSI, I want to go ahead and shut the well down. And I want 0 tries. Or 10 retries, whichever you prefer.
Hey, Dallas, got a question for you.
Yeah,
That's
go
basically
ahead.
mentioned analogs. Is there any way that we can, over IP, if it's DNP3 or Modbus, whatever, over IP, basically just communicate from our SCADA network? Well, not really the SCADA network, it's more of our, on-site, well, it wouldn't be on-site on most of these sites. It'd be, these are all centralized facilities. So the wells are mostly remote. All of our information when it comes to analog goes back to the facility for SCADA. Is there any way we can push the data?
That's a good question. I mean, I think you could probably plug into the Ethernet port with a secondary communication device. Might be the easiest way to do it. And then just go ahead and you could read the raw values right from the Red Lion side of it, potentially. I mean, the other way to do it, obviously, is to do like a site-to-site connection from our cloud to your cloud or what have you, and pass the data that way. But I think there's probably got to be some way. There isn't a way. I mean, you can. Yeah. Okay. Let me say it like this. Yes, absolutely. You could just read Modbus through the Ethernet port for those values.
Mm-hmm. Okay.
Yeah. So you could do it. Yes. Sorry. We would just create a static route for any Modbus traffic requests to go out to, Ethernet port 0 or Ethernet port 1. And if that's the only data you wanted to pull, that's no problem. You could pull. In my mind, when I hear Modbus, I'm thinking you want cards, you want all that kind of stuff, and you can get all that too. That's no problem. But if you just want tubing and casing pressure or the analogs, you can get just that as well. What you guys have your own system that you guys have developed?
What do you mean by SCADA? You talking about SCADA?
Yeah.
Yeah, we have an internal. It's GeoSCADA, so it's a Schneider product.
Oh, okay, gotcha. Understood. Yeah. Yeah, I mean, we play very friendly with anything that can communicate Modbus. Again, it's not, Modbus has been around for 100 years. So you have to communicate that way because it's just such a standard way to do it. But certainly there's some limitations outside of that we talk about. So I don't mean to talk bad about Modbus because we need it.
No, I agree.
Trust me.
I agree. It's old technology.
Yeah. In fact, it was invented the year I was born. So, but I don't want to tell you how old I am. So. Yeah, and I'll tell you, for yourself or anybody that's a heavy hitter in this market, or sorry, in the communication thing, you can pull up to this thing with an Ethernet cable, hook your laptop to it, and I mean you can have full access to the Redline administrative software. Should you, if you requested it, we can give that to you, right? It's password protected and this, that, the other thing, but you don't need any special software to set that to access it yourself from a laptop locally. We have had requests to access all of that remotely. So some of our customers, such as Continental, want to have access to the Redline administrative software. And so we just have to go through another little process to make sure we keep everything. We don't want to give Continental access to go in and change the passwords on us so that we can't access it or something like that, and we just want to make sure everything stays secure.
Yeah, understood.
But well, man, I'll tell you, this is a pretty easy crowd. I really appreciate your guys' time. There's many more avenues to this that we can discuss, whether it be rod pump, whether it be security, optimization. We're always here. It don't cost nothing to give us a call and have us log in and look at your well. That's probably half of one of our guys' days is just logging in and helping customers with optimizing, whether it be rod design or just the set points for the controller itself. But that's what we're here for.
Yeah, so Dallas, kind of question on that front.
Mm-hmm.
We've got a set of wells, a large subset of wells that we're currently using Ambient for, and then another subset of wells that we're using XBOC for. So within both of those platforms, there's a feature that we can download a card. It'll give us a kind of classification of that card, and then there's different ways to go about it. The different systems have different ways of recommending, but they have recommendations that basically say, hey, you're over pumping, you're under pumping. We suggest that you do X, Y, Z. Within WellWorks, is there anything in y'all's dashboard that is doing that currently? Or is that
so
works?
Let me get on my soapbox here. Okay, so how have you found those systems to be working for you with their suggestions?
So, I mean, it's been a work in progress with the Ambient side, especially early on, because we were one of the early ones back in 2019, 2020.
Okay.
To be honest, it was kind of a headache back then, but I think we've gotten much better. I think that their recommendations do make sense. I haven't spent a ton of time to go through and see exactly what that hit to production was. At the end of the day, yeah. I don't think it's doing anything crazy that our field guys can't do themselves. We've realized some electrical savings from it by reducing our strokes, but that's really the big one.
Okay.
In terms of card classification, which is why we've kind of started looking into XBOC further. Ambient, one of my big pain points with Ambient is the fact that they haven't really upgraded their card library classifications in like 5 years. It's been something I've asked for a while. And that's their disadvantage to XBOC, because XBOC, with the whole Theta system and all their 20 years of card capturing data, they've got those 30 different card classifications, and their analysis of a card in that little paragraph that it writes, I think there's a lot more information that we can use and optimize off of that than what we're getting from Ambient. So we're kind of trialing that system right now. But that's kind of where I see competition with you guys, because in terms of the controller, the interface looks different, but the things that you can do within WellWorks outside of the plunger velocity, which I'm going to be honest, I'm kind of new to, so I'd have to pick your brain a little more about what people are actually accomplishing and I guess benefiting from and measuring that and making decisions off of that. But we can do some of the similar things, it looks like, in our Spirit controllers that you guys can do. So I'm just trying to see where the differences are in each, right?
Yeah, well, so a couple of things. Now this is okay. So let me start from the beginning. Okay, so artificial intelligence, right? Now there's supervised and there's unsupervised, and so, okay, so what are we chasing? We're chasing the autonomous well control, right? We're never going to get there. I mean, we're always going to need everybody, you know. We're not going to, you know, but what we're going to do is we're going to be a lot more efficient with people's time. Okay, that's the way I kind of see it. Now, let me tell you, the reason why these systems fall flat on their head is in a supervised artificial intelligence world, they don't have a rod pumping expert behind the scenes classifying or labeling these cards. That's where they fall short. And I can just tell you that I have played with every artificial intelligent rod pump Dynograph software that I can find, and I can trick every single one of them in 5 minutes or less. Okay. So what we're doing, okay, we're amassing these cards like Theta, okay, which, you know, I traveled around the world and taught Xbox classes for 20 years. You know what I mean? So I know the system very well. As well, we were the ones who developed and brought to the market the Spirit controller. And I loved how you said that, because we started Spirit Global Energy Solutions in 2008 and sold it to what was at the time Norris Production Solutions in 2013. Okay, so very familiar with both systems. And I can tell you, you hit the nail on the head. Okay, so the labeling is where it is so important to get it right. And let me give you an example. Okay, if you have a gas interference card, if you want to train a supervised system to properly identify a gas interference card, you have to have 10,000 examples of that card. Okay. Now you can start with 1,000 and you can grow from there, right? Now, how many labels do we need? This is the other part I find a lot of our competitors, if not all of them, okay, fall short in this category. I can look at systems like Deviate, Ambient. They don't have enough labels, so they can't cross reference. They don't get to the right point, the solution. And therefore, you're back to what you said. Your pumpers can do it. You know, your production engineers can do it and do it better in most cases, because there's not enough labels. They don't have a rod pumping expert like a Matt Ragland or a Russell Messer or a Ken Nolan behind the scenes with a special software training the system, right? And so to me, that's where they all fall short. I don't know. I haven't seen the AI portion of Theta that much, okay? But, you know, I think that's where we separate ourselves in that world. Now, we haven't brought that to the industry. This would be another firmware update that comes for free, but that is absolutely and unequivocally what we're doing behind the scenes, is we are training the system. And what's so important is the two things. You got to have the right person training it. That's why Ambient hasn't changed in 5 years. They don't have that person, is my guess, right? There's only so many Matt Raglands and Ken Nolans to go around. And then number two, the labeling. You know, so we've identified 40 plus labels, okay? And I can't go into too many details because I don't want to give away all of our secrets, but I don't know anybody else that's even come close to identifying that many labels. And now you have to do it 10,000 times. So we need, 470,000 cards to get the system right, right? So that's absolutely and unequivocally where we're going. That's what we're after, is as best we can autonomous control. And we're doing this in small doses. So every week we have a team that just sits together and they label cards. Now we have a specific software we've built to go in and grab the data from our database and feed it to this team of experts. And now when it gets fed to this team, there's no company information, there's no production information. All it is a card. And it gets, so it's training the system. So every week by the week, we're getting there and getting better at it. So that's where we're going. That's why we built this system the way we have. One of the problems you have in a world of XBOC is, so the device out on location is a completely separate device. And there is a lot of opportunity for data entry error, okay? So you go put a rod string into the Smarten controller, okay? And then you go put a rod string into XBOC, or you pull the data across. Well, if you look at the database in Smarten, it's different than the database in Theta. And so there's a lot of errors we found in that system when we tried to do this kind of stuff, where we were just sitting there correcting data all day long, you know. So what we've built, we've tried to eliminate. There's one point to enter data, you know, and if there's something wrong, we're going to hopefully identify it, you know. So again, they're just this is just my experience talking. This is something we've been working on. Like you said, we developed the Smarten controller in 2008, developed the Lufkin controller in 2000. And so, you know, we're very rod pump centric. You know, I didn't even know what, you know, IIoT or artificial intelligence was, but I had to learn it because we want to push this technology forward. And so I think that, you know, that's what we're chasing, is this autonomous well control as close as you can get to it, but you have to do it right. And there's too many people that are selling the golden goose, you know, but don't understand the industry or the application itself. You know, I mean, there's companies out there selling pump off controllers based on fluid level calculations that Dr. Sam Gibbs couldn't get right. Okay, if Dr. Sam Gibbs couldn't get fluid level calculations from a downhole card correct, nobody's going to get it right. You know, so that's just, you got to be cautionary with this kind of technology in any industry, and specifically this one.
Yeah, I agree with your comments on Ambient. That's what I've been saying for a long time, is it's a bunch of data engineers, not petroleum engineers with a, you know, field background and card reading that I think they're missing out on. Let's see, I had something else there.
And I can show you like our system and stuff too on a separate call. Love to show you the little software we built to take these cards, to allow us to label stuff quickly. You know what I mean? And man, we'll take any insights on that you can share. But you know, this is what we're here for, is really, you know, that kind of stuff is what gets us out of bed, to be honest with you, right?
Okay.
Yeah.
Sorry. So I remember my question now. So you said you got people in the background that are classifying those cards.
Mm-hmm.
I guess how many operators is one person handling?
So it's not even based on number of operators. Okay, so we have a software that's going to that's feeding cards to this 3-person team. You know, well, I'll just tell you this. Okay, this is the fastest selling pump off control I've ever been a part of. We don't even have a proper sales sheet. We just started selling them just over a year ago, and you know, we have over 1,100 users and, you know, just about 800 wells in the system already. You know, so we're going to have to build that team, but we did do it right in that, and I can't exactly explain how this works. Our development team could, but our development team has built a specific software that's grabbing a number of these cards for our team to label. So it's not specific to operator. It's really just specific to time spent. And, you know, I think we're encroaching like 1,000 of each of these cards that we've identified as a separate label.
Got it.
Which will really start to get this system going, right? The 1,000 is sort of that tipping point from what I've told, and the 10,000 is when the system becomes an expert.
Got it. Okay. So then do we pay some kind of subscription fee or service fee to have the dashboard running at all times?
So good question. Okay. So, and so there is, depending on how you use this, right? So if you have Xbox and you say, hey, I don't want it, then you don't pay for it. And maybe I'm not supposed to tell you that. Okay. Now there is a cellular cost to it if you use our cell, or which either you're going to put a cell in or there's going to be a cost to that either way, whether you do an expensive radio network or, not expensive, but a radio network. There's communication costs no matter which way, if you want to get the data, right? Now, if you do want to use our interface and our cell, the starting cost is like $44 a month for both. that gets you unlimited data, unlimited history, unlimited features moving forward. We can show you the roadmap. These are all, we don't intend to charge or nickel and dime anybody. Now, there's other programs like DesignWorks that there'll likely be some sort of fee, just like there is for RodStar and or SRod. You know what I mean? But yeah, I mean, other than that, that's we don't intend. That's where we're going. We want to push this industry forward as best we can, as best we know how, and what you pay now is what you'll pay with some incremental fees. I'm sure 44 could be $47 in 3 years or something like that. But we've just revamped all that. I don't even know if Robbie's aware of this new pricing structure, but it is priced to be completely cost competitive with a radio network and or any other user interface fee that you may pay.
Gotcha. Okay, and you mentioned it does connect to Xbox, so you guys do connect directly to Xbox if we were to go that route.
Oh yeah. But to be honest with you, most of our customers use both. Okay, so Xbox is sort of like their 50,000 foot view, and so if it's in place, no problem, blah blah. And then we can be your 10-foot view when you need to be. Now I don't know how many wells you have in there or whatnot. You guys can make that decision, but that because there is a fee for us to go in Xbox, not from us, but from Theta themselves. There's a whatever, $300 a well per year plus 20% or whatever, however that works. There is a fee to put us in there, but if you find it useful to put us in there, by all means, we can definitely we play nice with Xbox.
Gotcha. Okay.
Yeah. That wasn't cheap, I'll tell you. And I wouldn't have made it cheap for us either, so I don't blame them. But we paid our dues.
10-4.
Yeah.
Cool. Well, I don't really have any other questions on my end. If you could send me any more documentation around that, like plunger velocity calc and what you guys are doing with operators to help optimize. I'm curious on that because I've never really run into that before. Yeah, I think that's my only ask at the moment. I guess Taylor or Trey, y'all got any questions?
No, not from my end, really. I think I might get Robert Love involved in this a little bit, Zach. We can kind of talk offline. And
Okay.
Yeah, so see how they approach that, what direction we go.
10-4.
That name sounds familiar for some reason.
Uh-oh. I don't recall where Robert worked at before, what his history
Yeah, I mean, anything else, reach out to Mr. Robbie on our side, and he can get it for you. Robbie, if you don't mind, let's get with Russell and get the plunger velocity presentation shared with the team.
100%. Yeah, no, I was just about to say, Zach, I can hook you up
Go
with
through
getting,
that. Yeah. You want to talk about somebody excited about plunger velocity? Just get Russell on the phone. He might jump on your desk if he's in your office. He's the one that patented it and really kind of stumbled upon it, and he's very passionate about it. He's very good at rod pumping. So, yeah, no, any of that kind of stuff. We always learn from our customers, and man, I just appreciate you guys listening to me this afternoon, and Robbie setting it up. And like you said, when you guys get that well fired up, it might be another a good time to just do another once over real quick too.
Yeah, Dallas, if you had any more information on the fluid level that y'all are bringing up and talking about, I'd like to know some more of that. More information.
So, on the green shot. Okay, sure, yeah. My developers and sales guys hate to, for us to talk about it, but man, it's real. I mean, we have 13 systems out there. I've seen, several fluid level shots come in. It's a pretty unique device. We're pretty proud of it.
Yeah, Trey, I'm glad you brought that up. You could copy me on that as well, Dallas. I'm just wondering if it's like a standalone. It's like a fluid gun you have connected to your casing side where you just constantly shoot fluid levels and can do it remotely, or if it's more of a calculation in the background based on what you're seeing it from the data in the VFD.
Yeah, well, I can answer that real quick. So it's not a calculated. It's probably one of the most accurate fluid level machines I've ever seen in my life, and it uses the well zone produced casing gas to shoot the fluid level. So with a 1 or 2 PSI pressure differential, we can shoot 10,000 foot fluid levels all day long, right? If you get less than 40, 50, 30 PSI casing pressure, things can get a little more challenging as far as, shooting as many fluid levels as you want in a day. But just out of the box, it shoots 10 fluid levels a day and 144 pressure buildups. We've compared this data with ESP. We've put it on an ESP that has live gauges so we can confirm, things like pump intake pressure calculations. But yeah, I have a little bit of data to share with that. I don't want to make any promises that I can't deliver on, but I can tell you I've been enough in tune with this product over the years to know that this is going to be a big phase for us.
Awesome.
Well, hey, I appreciate you guys. And Robbie, thank you so much for setting this up, man.
Yeah, thank you, Dallas, for getting on, and thank you, Trinity guys, for getting on too. For Dallas to get on his soapbox and preach a little bit.
Yeah, well, thanks. Yeah, and hey, you guys stay in touch, and if I get down Robbie's way, if you guys are down there, we'll definitely look you up, see if we can't get out for lunch or something.
Sounds good. No, appreciate the time, guys.
Thanks, everybody.
Appreciate it.
Have a good one.
Guys.